All right, in this video, we're going to talk about section 5.1, dealing with approximating areas under curves. And out of this section, we're going to be evaluating left, right, and midpoint Riemann sums. And also, we're going to use sigma notation to evaluate expressions in sigma notation. And we're going to evaluate Riemann sums for large numbers of subintervals. Okay, so the derivative of a function is associated with rates of change and slopes of tangent lines. We also know that antiderivatives or indefinite integrals reverse the derivative operations. And in figure 5.1 that you see here, it's going to summarize our current understanding and raises the question, what would be the geometric meaning of the integral? Okay, and here the following example is going to reveal a clue here. So if we have f of x, then here we can find out what f prime of x would be. And f prime of x will give us slopes of the tangent line. Now if we go in this direction with f of x, we can calculate the integral of f of x, which is dx. F of x dx, I'm sorry. But what would that give us? Well, what that's going to give us, when we take the integral of that function with respect to x, that's going to be the area between the curve and the x-axis. And that's what we're going to be looking at in this case here. We're going to be approximating area by using Riemann sum. Okay. Now in this case here, we're going to develop a systematic method for approximating areas under the curve. So let's say we want to consider this function y equal f of x. And it is continuous and non-negative on the closed interval a, b. So the goal here is to approximate the area of the region, which I'm going to call R, by the graph of f y equal f of x and the x-axis from this interval, x equals a to x equals b. So we're going to be finding this area of that shaded region that's bounded by the curve of y equal f of x and the x-axis, and on the closed interval from a to b. So we'll begin by dividing the interval, the closed interval ab, into what they call n number of subintervals of equal length. Okay, and in this case, your a is going to be x sub 0, and b will be x sub n, as you can see here. Now, the way we're going to find the length of each of these individual subintervals, which is going to be denoted by this notation delta x, we'll find that out by calculating b minus a divided by n. N, of course, is the number of subintervals that we'll use. Your endpoints are from a to b, so your upper endpoint minus a lower endpoint, b minus a. That's divided by n. That will give you delta x. Now here we have the definition of a regular partition. Suppose a closed interval AB is, well, a closed interval containing n subintervals of equal length. Delta x is equal to b minus a divided by n. And a is going to be your x sub 0, b is going to be x sub n. Your endpoints will be x sub 0, x1, x sub 2, and so on up to x sub n minus 1 to x sub n of the subintervals. Those are called grid points. And what they do here is create a regular partition of that interval AB. So in general, the kth grid point would be this. X of k is equal to a plus k times delta x. That is for k is equal to 0, 1, 2, all the way up to n. Okay. So now let's take a look at example 1 here. So here in this case here, if the interval 1, 9 is partitioned into subintervals of equal length, what is delta x? Okay. So we're just starting off with just the preliminaries here, because this will prepare you for everything else that I talk about in this video. Okay, so here we have an interval of 1 to 9, and we're partitioning it into 4 subintervals of equal length. That means n is equal to 4. So now we want to find out what delta x is. Well, in this case, by looking at this is the closed interval a, b. That means your a is going to be 1 and b is going to be 9. So delta x, or the change in x, is going to be b minus a divided by n. And in this case, your b is 9, so it'll be 9 minus a, which is 1, divided by n, which is 4. So if we subtract 9 minus 1, that would be 8. Then 8 divided by 4 is 2. So that means here, your delta x, or the change in x, will be 2. So the length of your subinterval, of each subinterval, will be 2. And then they ask you to list the grid points x0, x1, x2, x3, and x4. So if this helps, this is not necessary. You can draw a number line like this. So here you have x0, and then you got x1, x2, x3, and x4. And these are not drawn to scale. And according to this, your x of 0 is going to be, in this case, a. And a is 1. So if I start off with the 1 right here, that's your x of 0. And this represents, from here, from x0 to x1, that represents delta x. And delta x, we already found that out to be 2. So we're going to have an equal length of 2. So if x of 0 starts up at 1, then x1, add 2 plus the 1, you're going to get 3. And then another delta x means 2 plus the 3, that'll be 5. And then another delta x, which is 2, that means 2 plus 5, that gives us 7. And of course, another delta x, that will be, again, 2. 2 plus 7 will give us 9, and it should give us 9 because that last interval, or that grid point, will have to be that end point in that interval, which is 9. So here's what I have. x0, x of 0 is 1. X of 1 is 3. X of 2 is 5. X of 3 is 7. And x of 4 is 9. Okay. Those are my grid points for x0, x1, x2, x3, and x4. Okay. All right, next page, we'll look at this. Here in the kth subinterval, x of k minus 1 to x of k, which is going to be this interval right here. This is interval right here that I'm going to bold in black. We can choose any point called x star sub k, which is this right here. That's what they're choosing right here. And you're going to build a rectangle whose height would be f of x star sub k. That's going to be up here. That's this point that's on the graph of y equal f of x. And the value of f at x sub, which is going to be the value of x star sub k. That's what f of x star sub k will be. The value of f at x star sub k, as you can see in this figure. Now here we can build rectangles like this here. Now, I do need to mention that the formula for the area of a rectangle is going to be length times width. But in this case, we're going to be dealing with the base, which is down here, times the height, going straight up and down. Or height times base as they have it here. So here our base is going to be that delta x, which is this. And then the height would be that f of x star sub k. That's this point from the x-axis up to that point right there, f of x star sub k. And that'll be multiplied by delta x. So the area of the rectangle on the kth subinterval will be height times base, which is going to be f of x star sub k times delta x. K will be from 1 to n. Now, if we were to take the sum of all of these rectangles together, add them up, we would get an approximate area of R, and we call that the Riemann sum. Okay, so pretty much we're just taking the sum of all of these areas of every rectangle here from, let's say, from A to B. We call that the Riemann sum. And that Riemann sum would be this: f of x star sub 1 times delta x plus f of x star sub 2 times delta x, and so on up to f of x star sub n times delta x. Now, there are three notable Riemann sums: the left, the right, and the midpoint Riemann sums. Okay, so here's the definition. Let's suppose that f is defined on the closed interval a, b, which is divided into n subintervals of equal length called delta x. If x star sub k is any point on the kth subinterval from x of k minus 1 to x of k, for k is equal to 1, 2, all the way up to n, then this is how we would compute the Riemann sum. And I'm going to modify this a bit, because if you were to look at that expression, if you were to look at this expression right here, there's a common term that's in there. Notice that delta x is the common term that's in that expression. So if I factor out delta x, put the delta x on the outside, then what would go inside, what would be left inside, I should say, would be this: f of x star sub 1 plus f of x star sub 2 plus, and it goes on and on all the way up to f of x star sub n. And these are a little bit asterisks here that we're using. So I can take the delta x and multiply by f of the first plus f of the second, and so on all the way up to the f of whatever that last value is. And on the next page, you'll see what we mean by left Riemann sum, right Riemann sum, and midpoint Riemann sum. Here, the left Riemann sum, if we have the graph of y equal f of x, notice that the graph is touching the left vertex of each rectangle. It's touching the left vertex of each rectangle. Okay, so here's my left endpoint, another left endpoint, another left endpoint, left endpoint, left endpoint, and so on. You can see that the graph is touching every left vertex of every rectangle that you see here. Now for the right Riemann sum, in this case here, the graph of y equal f of x touches the right vertex of every rectangle that you see here. Okay. And for the midpoint Riemann sum, you can see, here's our midpoints right here for each rectangle. So the graph of y equal f of x touches every midpoint of every rectangle here. So that's what they mean by the midpoint Riemann sum. Okay, now if we look at example 2, Let's suppose the interval from -1 to 1 is partitioned into n is equal to 4 sub-intervals. What is the sub-interval length, or delta x? And then list the grid points x0, x1, x2, x3, and x4. And then we're going to identify which points are used for the left, right, and midpoint Riemann sums. All right, so now let's find out what delta x is first. We do have an interval from -1 to 1, and it's partitioned into n is equal to 4 sub-intervals. So n is equal to 4, and that's enough for us to find out what delta x is. Because here, this is a, that's -1, and b is going to be 4. So that means delta x is just going to be b minus a divided by n. So here your b is going to be 1 minus a, which is -1, divided by n, which is 4. So here 1 minus -1 is 2. And 2 divided by 4, that's 2/4, but we can reduce that to 1/2. So our delta x, that's going to be 1/2. Or, as a decimal, 0.5. That's just 1 divided by 2. Then the next thing we're going to do here is list those grid points. Okay, now we're going from -1 to 1. That's what our interval is restricted to. -1 to 1. Okay. So if that's -1, then the next one is going to be this. To get that, we just do -1 plus 0.5. So -1 plus 0.5, because that's our delta x. That's going to be -0.5. Okay. And then to get the next endpoint, or the next grid point, well, we just add 0.5 to -0.5. That will give us 0. And the next one we'll just add 0.5 to that. So it'll be 0 plus 0.5. That would be 0.5. And then finally, this will have to be 1, because 0.5 plus another 0.5, that will be 1. Okay. Our intervals from -1 to 1, so these are our grid points here. We start with -1, and then -0.5, and then 0, 0.5, and then finally 1. Okay. All right, now this problem continues on the next page, because they're asking for which points will you use, which points are used for the left Riemann sum. All right, now I want to write this in sub-intervals here, because I want you to see that the left endpoint of each of your sub-intervals will be your left Riemann sum, whereas the right endpoint of each of your sub-intervals will be your right Riemann sum. So if I write this in individual sub-intervals here, here's what I have. From -1 to -0.5, that's one sub-interval. The next one will be from -0.5 to 0. The next one would be from 0 to 0.5. Then the last one would be from 0.5 to 1. So now in this case here, the intervals or the endpoints that are on the left-hand side of each of your sub-intervals represent your left Riemann sums. Those are the points you'll use for your left Riemann sum. So I'm using each of these left endpoints for each of these sub-intervals here. So as you can see here, your points that you're going to use for the left Riemann sums will be these numbers here. -1, then -0.5, then 0, and then finally 0.5. And now the next question is which points are used for the right Riemann sum. In this case here, since we have these endpoints here, these subintervals here, your right endpoints, each right endpoint for each of these subintervals represent those points that you're going to be using for your right Riemann sum. So in this case here, what you'll use for your right Riemann sum would be these numbers here. -0.5, and then 0, then 0.5, and then 1. And then the next question is which points are used for the midpoint Riemann sum. Well, the midpoint would be in the middle of these two. And to get that midpoint, you just add the two endpoints together, add each endpoint together, and divide by 2. So like -1 and -0.5, if I do -1 plus -0.5, I'll get -1.5, but I need to take half of that, that's divided by 2. So it'll be -0.75 for that first one. And then for the next one, -0.5 plus 0, that's -0.5. Divide that by 2, that'll be -0.25, or -0.25. And then the third one would be 0 plus 0.5, which is 0.5 divided by 2, that'd be 0.25. And then finally, 0.5 plus 1. That's that last subinterval. Divide by 2, that would be 0.75. So for your midpoint Riemann sum, to find out what those points are, you will add each of the endpoints of that subinterval, of each subinterval, divide by 2. And those are it. Okay. All right, now let's look at example 3. Let's say I want to use the figures to calculate the left and right Riemann sums for f on the given interval and the given value of n. So here we got f of x is equal to x plus 2 on the interval from 0 to 5. And we're going to have 5 subintervals, so n is equal to 5. All right, so the first thing I need to do here is identify what delta x is going to be. So here I know what a is, that's 0. That's the endpoint, the left endpoint. B is the right endpoint on that interval, that's 5. And n is equal to 5. So that means delta x will be b minus a divided by n. And b is 5, so it'll be 5 minus a, which is 0, divided by n, which is 5. Well, 5 minus 0 is 5. 5 divided by 5 is 1. So delta x will be equal to 1. All right, so that means here, if I have 5 subintervals, that means x of 0, that's going to be what a is, that's 0. And then x1 will be adding 1 to the 0, that's going to be 1. x2, add 1 to the 1 will be 2. x3, add 3 to that will be, add 1 to that will be 3. x of 4, add 1 to the 3, you'll get 4. And finally, x of 5, Add 1 to that, you'll get 5. And now we need to find out what our left Riemann sum and right Riemann sums are going to be. Now, what I'm going to do here is write this into 5 sub-intervals here. And the way I do that is this. Since my left endpoint is 0, the other sub-interval will have to be from 0 to 1. From 0 to 1. The next one would be from 1 to 2. The next sub-interval will be from 2 to 3. The third one would be from 3 to 4. And the last one, well, the fourth one would be from 3 to 4. The last one would be from 4 to 5. So here I have 5 sub-intervals here. Each left endpoint represents the left Riemann sum that I will use here. Each left endpoint would be my left Riemann sum. So in this case, if I want the left Riemann sum, now the way I'm going to do that, I'm going to use that modified formula that I gave to you earlier, and I'll go ahead and bring that back up. That would be this right here. X times f of each one of those left endpoints on each of those sub-intervals. So it'll be delta x, but delta x, we found that out to be, of course, 1. So I'm going to have 1 times f of my left endpoints. These are my left endpoints, 1, 2, 3, 0, 1, 2, 3, and 4. So it's actually going to be f of 0, then plus f of 1, plus f of 2, plus f of 3, plus f of 4. So these are the left endpoints that I will use for the left Riemann sum. And then I'm going to evaluate each of those left endpoints here. Okay, now I'm going to use my graphing calculator to do this. First of all, I need to go to y equal 2, and I'm going to clear this equation out. I'm going to put x plus 2 into y1. So for x plus 2, I get the x for the x plus 2. And then I'm going to do second and table set. And what I want to do here is, under independent, I want it to highlight the word ask. So if your calculator starts off like this, when you do second table set, and your independent has auto highlighted, what you want to do here, use your down arrow key to put the cursor on top of auto, and then right arrow to ask, because you want the calculator to ask what values of x you want to enter. So you'll press enter to highlight the word ask. And then go to second, and then graph for the table, and then hit delete if you got values of x in here. Okay? So what I'm going to do here is type in my x values, 0, 1, 2, 3, and 4. So I'll start with 0 and hit enter. So for f of 0, it gives me the answer of 2. For f of 1, type in 1. Gives me 3. For f of 2, type in 2. It gives me 4. For f of 3, type in the 3. You'll get 5. And then for f of 4, type in the 4. You'll get 6. Okay? So that means here, I'm going to have 1 times f of 0 is going to be 1, plus f of 1, that's 3, plus f of 2, that's going to give me the 4, and forgive me for moving this calculator around. Then for f of 3, that's going to be 5, and f of 4, that will be 6. Okay? And you can do this pretty much easily 0 plus 2, that gives, I'm sorry, 0 plus 2, that would give me actually 2. I don't know where that 1 came from. And I even have it right here. At 0 is going to be 2. So f of 0, that's 2. F of 1, 1 plus 2, that's 3. F of 2, 2 plus 2, that's 4. F of 3, 3 plus 2, that's 5. And f of 4, 4 plus 2, that would be 6. Now if we add, this will be 1 times. 2 plus 3, that's 5. Plus 4 is 9. Plus 5 is 14. Plus 6 is 20. And 1 times 20 is 20. So my left Riemann sum is going to end up being 20. And we could have easily gotten those left endpoints from this graph right here. You see this line of f of x equals x plus 2, that's touching the left-hand side of each of these rectangles that you see here. Now, let's find the right Riemann sum. The right Riemann sum. And I'm still going to use that delta x is equal to f of x1 plus f of x2 plus f of x3 plus f of x4 plus f of x5. In this case here, notice in this graph here on the right-hand side, this graph touches each right vertex of each of those rectangles here. Okay? And if you were to look at your right endpoints on each of these sub-intervals, you'll see that it's going to be f of 1, f of 2, f of 3, f of 4, and f of 5. And my delta x is still going to be 1, so it'll be 1 times f of 1 plus f of 2 plus f of 3 plus f of 4 plus f of 5. So it'll be 1 times, and I've already got what f of 1 is, f of 2, and f of 3, and f of 4. Let's find out what f of 5 is by typing in 5 for x. That would give us 7. So from this, my f of 1 is 3, plus f of 2, that's 4, plus f of 3, that's 5, f of 4 is 6, and f of 5 is 7. So in this case here, if I add, let's see, 1 times 3 plus 4 is 7, plus 5 will be 12, 12 plus 6 is 18, 18 plus 7, 25. And 1 times 25 is 25. So my left Riemann sum, we found that out to be 20. And my right Riemann sum is 25. Okay? So that's how we find the left and the right Riemann sums for this function. Okay? Now, example 4. Here we're going to use the figures to calculate the left and right Riemann sums for f on the given interval and the given value of n. Here we got f of x is equal to 3 divided by x plus 3 on the interval from 1 to 5. And n is going to be 4, so we have 4 sub-intervals that we will be dealing with. All right, in this case here, the interval is from 1 to 5. So that means a is going to be 1 and b is 5. And we have n to be equal to 4. So that means delta x, we can find that out by doing b minus a divided by n. Well, the b is 5 and the a is 1. So we have 5 minus 1 in the numerator divided by n, which is 4. 5 minus 1 will be 4, so 4 divided by 4 is 1. So our delta x will be 1. So pretty much our grid points here would be x of 0, that's going to be what a is, that's 1. Then x2, that'll be 1 plus 1, that'll be 2. x3, 2 plus 1, that'll be 3. x4, wait a minute, I am so out of this one. This should be x0 is 1. This should be x1, that's going to be 2. And then x2 would be 3. X sub 3 would be 4. Yeah. And x sub 4 would be 5. Yeah. So those are my grid points as indicated here in this graph, in these two graphs here. All right, but my subintervals will be this. If we're starting from 1 and my delta x is 1, that means 1 plus 1 would be 2, so it'll be from 1 to 2. The next one would be from 2 to 3. The next one would be from 3 to 4. And the last one would be from 4 to 5, because there's supposed to be 4 subintervals, since n is equal to 4. That's going to help me identify my left and right endpoints to use for the left and the right Riemann sums. So if I find the left Riemann sum, that's going to be this. My delta x is going to be 1, so it'll be 1 times f of this first left endpoint, which is 1, plus the next left endpoint, that will be 2, plus f of the next left endpoint, that would be 3, plus f of the last endpoint, which will be 4. So these are the left endpoints that I'm using to find my left Riemann sum. So here I'll have 1 times, and let's use our graphing calculator to do this, to get our values for f of 1, f of 2, f of 3, and f of 4. If I go to y equal 2, let's clear this equation out. And I'm going to enter that 3 divided by x plus 3 in the calculator, so this will be 3 divided by xt theta n for the x plus 3. Now I've already got the table set to ask what values that I want to use. So I'm going to go ahead and do second and graph for the table. Let's delete those x values by pressing that del button for delete. And now let's go ahead and ask what values are there going to be for x equals 1, 2, 3, and 4. So for x is 1, f of x will be 6. For 2, type in the 2, f of x will be 4.5. And then for 3, type in the 3, you'll get 4. Then for f of 4, type in the 4, you'll get 3.75. Okay, so here's what we got. F of 1 was 6. F of 2 was 4.5. F of 3 was 4. And f of 4 was 3.75. So 1 times, and I'm going to go back to the home screen, so I'll do second quit, or second mode. 6 plus 4.5 plus 4 plus 3.75. And that's all going to be multiplied by 1. You'll get 18.25. And 1 times 18.25 is 18.25. So my left Riemann sum will be 18.25. Now for the right Riemann sum. That's going to be that delta x, which is my 1, times, and now we're going to do the right Riemann sum and find their values. So it'll be f of 2 plus f of 3 plus f of 4 plus f of 5. So the 2, the 3, the 4, and the 5 are my right Riemann sum. So I have 1 times. Let's go to y equal to. That equation's already there, so second table. And I've already got the 1, 2, 3, and the 4. Let's do 5. So for x equals 5, it'll be 3.6. So I know what f of 2 is. That's the 4.5. Plus f of 3, which is 4. Plus f of 4, that's 3.75. Plus f of 5 is 3.6. So now we got 1 times. Let's see, go to second and then mode to quit. 4.5 plus 4 plus 3.75 plus 3.6. You'll get 15.85. And 1 times 15.85 ends up being 15.85. Now I do need to mention this. That one that you see in front of each of those brackets, that's your delta x. Will it always be 1? The answer there will be no. That delta x could be something like, let's say 1/2 or 0.25 for 1/4. You'll take that and multiply by whatever delta x is. Okay? So that right there is example 4. Now example 5, there are 4 parts to this, and this continues on the next page. Here you're going to complete the following steps for the given function, interval, and value of n. In part A, you're going to sketch the graph of the function on the given interval. Part B is to calculate delta x and the grid points x0, x1, up to x of n. Then part C, it illustrates the left and right Riemann sum and determine which Riemann sum underestimates and which sum overestimates the area under the curve. And then you're going to calculate the left and right Riemann sum. So that's parts A through D. We're going to start with, and here we got the function f of x is equal to 2x squared plus 5. The interval that we're dealing with is from 3 to 8, and we got 5 sub-intervals. N is equal to 5. Okay, so on the interval 3 to 8, we're going to sketch the graph of f of x is equal to 2x squared plus 5. And here in this problem, they do give you a choice of graphs here. So if I go to y equal to, clear this equation out, and then type in that 2x squared plus 5. So I have 2, get the x by pressing xt theta n, and then hit x squared to square it, then plus 5. And I'm going to go to my window here, because if you look at this window here, I'm seeing from my x, it will be from 0 to 8, so I'll use 0 for the x min. X max will be 8, my y scale, x scale will be 1. And then I'm going to do, for the y min, 0, y max will be 140. Y scale looks like it's going to be 10, so let's use that. And then press graph. Now we just focused it on from 0 to 8, so this is like 1, 2, 3, which will be about right here. And if you were to look at these graphs and compare this graph with the ones that they give you, it will have to be graph C. So graph C would represent the sketch of 2x squared plus 5 on the interval from 3 to 8. Okay? They only consider this part right here. Okay? Okay, so that's part A. Now I'm going to go to the next page for part B. calculate delta x and the grid points. We're going to calculate delta x and the grid points here. Now, in this case, our interval is from 3 to 8. And the number of intervals here, n, will be 5, or the number of subintervals will be 5. So here's A right here. That's your 3, and B is 8. So that means delta x in this case is B minus A divided by n. That's how we calculate delta x. So your B is going to be the 8 minus A, which is 3, divided by n, which is 5. So if I do 8 minus 3, that's going to be 5, and 5 divided by 5 is 1. So that means delta x will have to be 1. All right, so now let's find out what our grid points here will be. We start with x sub 0. X sub 0, that's going to be that left endpoint in that interval, starts with 3. But keep in mind delta x will be 1, so that means x1 will have to be, add 1 to that 3, you'll get 4. And then for x2, add 1 to that 4, you'll get 5. x3, add 1 to the 5, you'll get 6. Then for x4, add 1 to that 6, you'll get 7. And then x sub 5, add 1 to the 7, you'll get 8. And we have to stop right there because our endpoint on the right is 8. So these are all the grid points that we will use here. 3, 4, 5, 6, 7, and 8. So that's part B right there. Finding out what delta x is, and then identifying our grid points. Now part C is illustrating the left Riemann sum and illustrating the right Riemann sum. Now here you're given the graphs, or choice of graphs. You have to pick the one that illustrates the left Riemann sum, and then you have to pick the one that illustrates the right Riemann sum. And by looking at this, keep in mind your left Riemann sum is where the graph touches the left vertex of every rectangle. The left vertex of every rectangle in that graph. So here it has to be graph C, because that graph touches each left vertex of every rectangle that's given here. And then illustrate the right Riemann sum. Well, the right Riemann sum will have to be the graph that touches every right vertex of every rectangle. C would not do it because it's touching every midpoint. And A will not be it because notice there's an extra rectangle here from 2 to 3. And we don't have a 2 here in this case. So it has to be B. Because you can see here the graph touches every right vertex of every rectangle from 3 to 8. Okay. So the next question is this. Which Riemann sum underestimates and which sum overestimates the area under the curve? Well, let's look at this right here. Our left Riemann sum, which is up here, notice that there is a space under the curve that's unaccounted for. So that's underestimating the area. But for the right Riemann sum, notice that you got triangles of pieces of each rectangle that's above the graph of y equal f of x. So here, that right Riemann sum will overestimate the area. So the correct answer for that would be this. The left Riemann sum underestimates the area, and the right Riemann sum overestimates the area. Okay. Now, part D is to identify or come up with the left Riemann sum. And I will have to do this on a separate sheet of paper because I don't have any space down here. All right. Well, first of all, let me identify my endpoints here, or my subintervals. All right, so there are 5 subintervals in this case because n is equal to 5. So those subintervals starts with this. We're starting with 3, so that means our delta x was 1, so it would be from 3 to 4. That's one subinterval. The next one would be from 4 to 5. The next one would be from 5 to 6. The fourth one would be from 6 to 7. And the last one would be from 7 to 8. Okay. Each distance on that subinterval has to be 1 because my delta x is 1 that I found in part B. So now this is going to help me find my left Riemann sum. And of course, delta x, by the way, is going to be 1. So my delta x from that formula that I gave you on one of those pages. Okay, here it is up here. Delta x, and delta x is the 1. So it'll be 1 times f of each left endpoint. F of 3 plus f of 4 plus f of 5 plus f of 6 plus f of 7. Okay. All right, what I'm going to do here is pull out my graphing calculator. And my function was f of x is equal to x squared plus 5, which 2x squared plus 5 that I have here. And I've already set up the calculator to ask the x values that I want to choose. So I'm going to do second and table. Let's delete by pressing the DEL button to delete all those x values. And in this case here, we're going to do 1 times. Let's find out what f of 3 is. So if I type in the 3, press enter, it'll be 23 because of the fact that 2x squared, x squared is, well, 3 squared will be 9 times 2 is 18 plus the 5 will be 23 plus f of 4, that'd be 37. And then f of 5, press the 5, that'll be 55. F of 6, press the 6, 77. And then f of 7, that would be 103. Yeah. And let's go ahead and bring down the 1 times. And I'm going to add all these numbers up together. And here I don't need the bracket. I can just say parentheses here. So 23 plus 37 plus 55 plus 77 plus 103, that'd be 295. And 1 times 295 would be 295. So my left Riemann sum will be 295. So the left Riemann sum is 295. Okay. Next, I'm going to find the right Riemann sum. So I'm going to use that same formula, so that's delta x, but delta x is 1 times each right endpoint of each subinterval, as you can see. F of 4, f of 5, f of 6, f of 7, and f of 8 added together. So it'll be f of 4 plus f of 5 plus f of 6 plus f of 7 plus f of 8. So I have 1 times, and I know what f of 4 is, that's 37, and f of 5 was 55, f of 6 was 77, f of 7 was 103, so I need to evaluate what f of 8 is on the calculator. So let me go to second graph of the table, and then type in the 8 for x equals 8. That would be 133. And then let's add 37 and 55 and 77, 103 and 133. That would be 405. So that means I'm going to have 1 times 405, which is 405. So my right Riemann sum ends up being 405. Okay? So that's how I calculate the right Riemann sum and the left Riemann sum. Okay? Okay. This is only going to be part 1 of section 5.1, dealing with approximating areas under the curves. There will be a part 2 to this video, so do be on the lookout for part 2, which deals with sigma notation and also using Riemann sums along with the sigma notation to calculate our left, right, and midpoint Riemann sums. I'll be talking about that in the next video, so be on the lookout for that.